Good day, students. As you have seen, what we have today is transformations of polynomial function. So, what do we mean by transformation? A change in characteristic of a given function, let's say f of s, so that if another new function g of s is formed. So, we start by giving instances how the change in f of x will affect new function g of x. Because of limited space, we will treat it one at a time. Please, when we are going through it, make sure that you understand each concept for you to be able to plot a graph and give some reasons. A graph of g of x, once we have known how the transformation of f of s is formed. So as we have seen, transformation horizontal translation, when it translated horizontally, the graph shifts right or left for horizontal. In this case, f of x, the function that to be translated will be of this type: f of x minus h. I hope you are seeing it. This is a closed function. I call it a closed function because the formation of for you to be able to get horizontal translation, the f of x must be in a closed form. This is a secret when you are giving your reasons of forming a new transformation g of x. Do not include closed function. It's for you to know how the f of s is translated to g of x. The secret is that for a closed function, we can use the nature of the closed function to find the horizontal translation, and as well the shift or shrink in the s axis. So it is in this form. F of x is given in this form. So when translated as g of x, it will be of this type: s plus or minus a all raised to power n. If h is equals to minus a, when the h is equals to minus a, I hope you are seeing it. When if h is equals to minus a unit left, that is the new graph of g of x will move to the left a unit. If h is equals to a, the graph of g of x formed from f of x will move a unit to the right. So when g of x of f of x, that is the function formed from f of x, has a constant term, that is intercept on the g of x, that intercept, if it is plus k, the graph of g of x will move up, because it's plus, it will move up vertical. If it is negative, the graph of g of s form will move downward vertical. So this is the first thing. The second is vertical translation. Having known the horizontal translation, we now move to vertical translation. I hope you are seeing it and you are following. So for vertical translation, the function must be in this form: f of x plus constant. F of x plus constant. Unlike this f of x, which includes the change in the translation, the left on the right. Mind you, horizontal translation occur in the s axis, while vertical translation will occur in the y axis. So the function for you to translate in vertical translation from f of x to new g of x must be in this type: f of x plus constant. So in my own secret, I call it open function. Call it open function because it doesn't include any constant inside. It's just a whole function for itself. its constant is outside. So in this case, it is vertical translation. I call it open function. So when this function is translated, it will be of this type: g of x equals to x raised to power n plus or minus k. So if we translate this function, it will be of this type. See the difference between them. Vertical translation is x raised to power n plus or minus k, and vertical horizontal translation is x plus or minus a in bracket, close bracket, to the exponent of n plus or minus k. So see the difference. So, and when k is plus, it will move what? K unit up. This k is a constant. If it is k is plus, it moves k unit up, vertically up. If k is minus, it will move k, I hope you are seeing it, k unit down. It will move k unit downward vertically. So we can now proceed. This is for vertical translation, and this is for what? Horizontal translation. Be aware of the function, because if you be able to know the function, every other things will be easy for you to translate it or changing the characteristics like shrink or stretch. So we are coming to that. So the next is what? The next is what? Horizontal stretch. We have talked of what? Translation. We have talked of translation. Now we are talking of what? Horizontal stretch. I haven't talked of translation. The next is what? Horizontal stretch or shrink. Horizontal stretch or shrink. Graph stretches away from what? The graph stretches away or shrink up or down. So the graph stretches away from, I hope you are seeing it, or shrink towards x axis. The graph straight, I hope you are seeing it. The graph stretches away from or shrink towards x axis. So for horizontal stretch or shrink, the graph stretches away from or shrink towards x axis. In this case, the function to be used to, in order for this to be possible, is f a x. So a is what? Unit or factor unit that enable the graph to stretch or shrink. So if it is in this form, example of how the g of s will look like. I hope you are following. When we give examples, you may return to this table of value to see how our example match exactly with what we are explaining. So horizontal stretch or shrink, we have talked of what? Translation. Now we are talking of stretch and shrink. So g of x is equals to ax raised to power n. If you still look at it as I have told you, it is still a closed what? A closed function. All translation, stretch and shrink in the exercises must have a closed function. So it is this a will determine how the graph of g of x will shrink or stretches. So to do that, when x is equals to what? 1 over a. To obtain 1 over a, divide both sides by 1 over a, so that s will be the subject of the formula. So by that time, you know that x is equals to 1 over a. So when s is equals to 1 over a, the graph will do what? Shrink by a factor 1 over a. Because a fraction, it will shrink. If it's a whole number, it will stretch, shrink by a factor 1 over a. The graph will shrink by a factor 1 over a if g of x is equals to what? If g of x is in this form, 1 over a. I'm talking of s sizes now. If g of x is in this form, s raised to power n, 1 over a times s all raised to power n. This will occur, like I told you, for horizontal shrink or stretch. Try to make s of the subject, in as long as the function is a closed function. Once you make it a subject of the formula, s the subject of the formula, you know when you open it, this will be 1 over a raised to power n, s raised to power n. So if you multiply it here, it will be a raised to power n g of x, s raised to power n. And no cancel out, you'll be having a g x is equals to x. So it's determine how the graph of g of x shrink or what? Shrink or stretch. It's a whole number here, it will stretch. If it's in this type, when you divide it, it will be a fraction, so it will shrink. So if g of x is equals to s over a all raised to power n, this will occur when s is equals to a. So if s is equals to a, the graph will stretch by a factor. The graph will stretch by a factor a unit. So this is for what? Stretches. We have treated translation, horizontal and vertical. Now we are treating horizontal stretch, shrink, and vertical stretch, shrink. So while f of x is given, g of s you will form. It must be a closed function. You always look at the graph, the function. If it is a closed, you know, for you to interpret the shrink or the stretch, divide both sides by the constant that attached to the leading term, not all the term. The constant that attached to the leading term that has the highest exponent, divide that constant by going to both sides, neglecting the unknown exponent. By that time, you will see how the value of x that shrink. If it is a whole number, it will shrink by a fraction. If it is a fraction, it will multiply. That is, it will be a whole number. S will be equals to a when you divide both sides by a. That will, when you multiply both sides by a, that will give us stretch. In general, if it is a fraction, it will be a shrink. If it's a whole number, it will be what? Stretch. For what? Horizontal stretch or shrink towards what? Exercises. Now let's go to vertical stretch or shrink. Vertical stretch or shrink the graph will do what? The graph will stretches away from or shrink towards y-axis. The graph will stretch away. I hope you are seeing it. This graph will do what? Stretch away. The graph will stretch away from or shrink towards the graph will stretch away. For vertical, stretch or shrink. Graph will stretch away from or shrink towards what? Y-axis. This is y-axis. The graph will stretch away or shrink. If it is what horizontal, the graph will stretch away or shrink towards the x-axis. So this is vertical. For this to be possible, the function must be multiplied by what? A constant, a dot f of x. You see this one, the function itself is a product of the x and the what? And a constant for horizontal stretches and shrink. For vertical stretch or shrink, the function will be multiplied by a constant. So the g of x form, because you have to know this table before we can go into examples. You must refer to this table. You can, while I'm doing this thing, you can use a paper to write exactly what I'm doing here. Put the table of values so that you can as well compare it with the table of value in the chapter 4 of your algebraic textbook. I elucidated the point here, I buttressed the point here so that it will be easy for you to understand the concept of transformation, because if you don't understand it, you won't be able to give reasons or plot the graph. So g of x will be of this a s raised to power n. So you are seeing it, this one is still a closed. All closed functions attached to horizontal x-axis, whether translation or stretch, while open function will attach to the vertical, whether translation, shrink or stretch. This is open, this is closed. It will always close with this exponent, while this one is free, acting as a product. So you don't need to find the value of s. In this case, the stretch or shrink is the same. There's nothing because it's the g of s you are looking for. So in this case, so I hope you are making sense. So the second is g of x is equals to, if it's a whole number, it stretches. I always told you that for a whole number, it stretches by a factor of a. Stretches by a factor, to stretch by a factor of a. To stretch by a factor of a, because it's a vertical we're treating. It will stretch by a factor of a vertically. A factor of a vertically. If it's a fraction, it will shrink by a factor. If it's a fraction, it will shrink because of limited space. A fraction, it will shrink. It will shrink. I hope you are seeing it. If you don't see it, you hear what I said. It will shrink. This is shrink by a factor. To shrink by a factor 1 over a. So to shrink by a factor 1 over what? A. So for vertical stretch or shrink, the graph stretches away from or shrink towards y-axis, and the function to to use in this in order to form g of x will be a product of the function and a constant. So that g of x form will be a raised to power s minus s to exponent n. A times s to exponent n. In this case, it stretches by a factor a whole number. If it's a fraction, it will shrink by a factor 1 over a. Always pause the video, go what we did. Still have a question to ask, please endeavor to do so. So we can proceed. So finally, it's a reflection. Having treated horizontal translation, shrink, stretches, and then with the vertical. Then the next is what? Reflection. Reflection will tell you how g of x, the position of g of x with respect to its initial function gonna look like. So the next is what? Reflection. If you haven't following by what, if you are not following up, that is writing what I have saying in the piece of paper, refer immediately to your what will I say, the table that you have in your chapter 4, so you can be seeing it, although there are some modifications that will enable you understand the concept of transformation of polynomial function. So for reflection, the graph flips over s or y axis. You know what is flipped? If this is x axis, the graph will look like this. We touches it and don't cross it. If it's a y axis, the graph will look like this. Just touch one side and that is flip. So it doesn't crosses it flip over it. So reflection graph flips over x or y axis. So the function to obey this is f minus x. This function, see that the function itself has negative inside. So g of x to be formed will be of what? Minus x raised to power n. If this n is positive, g of x will be s raised to power n. If it's negative, g of s will be negative s raised to power n. So if it is in this form, it will flip over what? Over y axis. G of x, the graph of g of s will flip over y axis. If it's in a product, the f of s is the multiplication of a constant with a function. G of x form will be x minus x s raised to power n. So this is where a little bit understanding is needed. So in this case, it will flip over what? S axis. So do you understand it? Most odd degrees graph of g of x, like if this is 3, most of reflection occur in the y axis. If it's positive, if it is even, most of the reflection occur in x axis, although not stated in your own chapter. But you have to know this secret. Irrespective of this, I mean, if x n is 3, the reflection occur in the y axis. If n is even, maybe 2, 4, and whatever, the reflection will occur in the what? X-axis. Odd axis, odd degrees reflection y-axis vertically. Even degrees reflection occur x-axis. So, having seen the functions that will enable you to know where the reflection occur, the formation of g of x, then we can now go into some examples. I clean the board. Any question? So this is the table of values to explain what we are going to do now, because it's helpful. You can visit the table of value as frequent as you like in order to master the concept of what? Reflection of polynomials. Once you have learned it, plotting the graph or giving reasons for your actions will be at the tips of your finger. Will be at your fingertips. You can easily consult it without any problems. So we are still on what? Transformation of what? Polynomial functions. Transformation of polynomial So if you are ready, I'm ready. The first example, number 1, f of x is given. This is the function that is given. You are required to describe the transformation of the function f of s. Okay, you are given f of s equals to s raised to power 4, and you are required to describe the transformation of the function g of x equals to s raised to power 4 minus 3 in f of x. Do you understand? Describe the transformation of g of x on f of x. So looking at the two functions, they have something in common. They have the same first term variable, because g of s depends on f of x. We can straight interpret it. If you have your table of values immediately, this g of x is in the form g s is equals to what? A s raised to power n plus k. So based on what I gave you and explained to you, if you look at this, you will see that this is an open function. So I told you for open function, anything open function occur in what? Vertical axis. So all the translation, shrink, and whatever you have to say must be on the what? Vertical axis. If it is a closed function, or whatever you say must be in what? Horizontal axis. So because you are asked to describe the translation of this g function, g of x, on f of x, so you refer to the table of value I gave you and notice that g of x is in this form, s raised to power n plus k. So therefore the graph of g is a vertical, you must give reason, vertical translation is a vertical translation. This is the constant. there is a reason I gave you for open a function. Vertical translation of what? Vertical translation of a by a factor. Vertical translation by a factor of what? 3 units. 3 units up of what? Of the graph of f. So do you understand it? The constant are still the same, so you can't talk of shrink or stretch, since the constant is 1 1. Only difference is this: the vertical translation, the translation itself. The shrink or the stretch was not stated by the any constant, so you now talk of the translation. Therefore, the graph of G is a vertical translation by a factor of 3 units up, because it's positive up. If it's here is negative, it will be down, of the graph of what? F, because it's based on the graph of f. So if you look at the graph, because you're asked to do what? To describe the translation, to describe the you are asked to describe what? The transformation of g of x, of f of x, and plot the graph. Describe the transformation of g of x from f, and plot the graph. So describe the transformation of g of x from f, or of function f, and plot the graph. So the first f of x will look like this. If you look at the graph, check your graph, check this, confirm this from your graphic calculator. Go to the website I gave you and confirm it. It will look like this. This is a function of f of x. So this is how it looks like. So this next, once this one you are asked to describe, will look like this. At this point, this is minus, this is plus 3. So this is a graph of what? G of x. So this is what we are asked to describe and plot. Therefore, the graph of G is a vertical translation by a factor of 3 units. Vertical translation by a factor of 3 units up of the graph of f. So this is the first thing. Once you describe it and plot the graph, you get a full mark. So we can now go for example 2. If you have any question, ask me so I can provide the answer for you. S minus I5 raised to power 4. So it is the same thing. Describe the transformation of g of x from f and plot the graph. So this is the second. I hope you are seeing it. So giving you f of s equals to s raised to power 4, and a second function g of s equals to s minus 5 raised to power 4, we are asked to describe the transformation of g of x on f or from f. Describe the what? The transformation of g of x on f, and plot the graph. So if you look at this function, it is of the form g of x equals to s minus h raised to power n. So what did I tell you about closed and open function? if you look at this given function, it is a closed function, so therefore all the translation, shrink, stretch will be on what? S-axis, except in a situation where it has a constant plus k. If it has a constant, you explain this part, every of this part on what? S-axis, and then make a reference of plus k, because plus k, the constant, is obtained when this value is equals to 0. It depends on the vertical. So after you explain everything about the closed function on the S-axis, you now state this one, if it's plus, and also plus k unit up the vertical axis, or k unit down the vertical axis translation. This is a translation, not a shrink. Shrink will occur on the value here. If it's here, if it is attached here, you talk of shrink. If it is open, it will be here. It is a shrink always attached to the leading term of the word of the polynomial. So if it is a closed term, it will be here. You talk of shrink and stretch. If it is open, it will be here. Every other things depends on what? Translation. So as we have seen, so this graph, this function, it is of this form. So once it is of this form, everything will be what? Stated on the what? Horizontal axis. So the first thing is to find the value of h. If you equate the two functions, it will be what? S minus h, because this is n, it will be equals to 4. S minus 5 equals to 4. 4 can cancel out. We now have s minus h equals to s minus 5. This cancel out, sign cancel out. We have h is equals to what? Plus 5. So once we have gotten your h to be plus 5, you can now put this, our h is equals to what? Plus 5. You can now rewrite this given function. Write it very well. It will be g of x equals to what? S minus in bracket plus 5, because h is plus 5. So writing it, keeping the minus, just know that is plus 5 raised to power 4. So once we have done that, you can now give your reasons. You can now describe it. You can now say hence the graph of g, or you say therefore the graph of g of x is a horizontal translation hence the graph of g of s is a horizontal translation by a factor of 5 unit to the right of what? To the right of the graph, because the changes in the graph of f of x you are determining. So the graph of g of x is a horizontal translation by a factor of 5 unit to the right, because it's positive. It will be to the right of the graph of what? F. So this is the reason, the description you have to give. Therefore, once you have rewrite it very well so that you can see how h looks like, that is, h is what? Giving us the translation right or left of the s-axis of in the s-axis of the graph of f of x, in the s-axis, because horizontal is what occur in the s-axis, while vertical occur in the y-axis. So the graph of g of x is a horizontal translation by a factor of 5 units to right to the right. To the right of the graph of f. So having stated it, you can now, this reason is very important because there are not much formula in given in a transformation of polynomial function. You have to give reason before you plot it. So we are still in SU of 4. Here is 0. It is in the 0 that it crosses. So this graph, because we are told that it's 5 to the right. So here is 5. Once you get to the 5, let me bring it a bit close because we don't have enough space. So once you put it here, you write your 5 here. You can now, if you want to, this is how it may look. We are still on this graph, but in this case, this is our 5 because it is a transformation on the f. So if here is 5, the graph will look like this. So are you seeing it? If you plot it on different graph, you have to put this axis here with nothing here. It will be 0, and then go to the 5 and plot it. So this is a transformation that they want you to see. Initial function is s raised to power 4, and g of s is what the transformation they really wanted you to explain and plot. In order to be able to explain g of x, there are some rules, formulas you have to apply. So here we notice that g of x is a horizontal translation by a factor of 5 units to the right of the graph of f. This is how it may look. Have any question? Please, if you have putting down the table of values of this transformation of polynomials function, looking at it, you'll be seeing the function, what we are doing, what I have explained to you in the past. You see that it is very easy. It is not a confusing topic. So this is a closed function. The other one is open function. So can we continue? All right, we can continue. So from here, the next is to the third example. If you haven't written down the table of value, please pause the video, go back and put the table and return to this. Once you have put the table down, write it in a paper. Read it once and then come to this example so that you can be following immediately. Or if you have understood the initial concept, then let's continue with the example. So describe the transformation of g of s on f and then plot the graph. This is the third example. So you are given g of x equals to s plus 1 raised to power 6 minus 4. So if you still look at this, what type of function is this? Let's see if you understand it. What we have been doing, there is no constant. It is only the function, changing the function. Now there is constant. So what type of function is this? This is a closed function because of this. So in the form, it will be like this. I hope you are seeing it. So this g of s is in the form g of x equals to x plus or minus a raised to the power n plus or minus k. So it is in this form. This is a closed function. So compare the function I gave you when the function f of x is equals to s minus h. So this is the original function you will compare with this so that you can find h. So s minus h is equals to s plus 1. S can cancel out. Divide both sides by negative to give us h equals to minus 1. Once we have gotten minus 1, you now know that a is equals to minus 1. If you are looking at the table I gave you, you know that a is equals to minus 1. So you can rewrite this given function. Rewrite. We have g of x equals to what? X minus, remember to put the minus because it must be in this. The function that translated this given function is f s minus h. So you have already gotten the value of a. So this is the function that translated for you to get g of x. So g of x must obey the initial function to be x minus our a is minus 1. Minus 1, you put bracket, and k is what? K is minus 4. So do you understand it? If you open bracket, it will be plus again, s plus 1. You get this function. But this function was formed, this g of s was formed initially from general formula of a closed function. For any closed function, you must always apply this to do what? To find the value of h, in as long as we have a constant attached to the variable. So having done it, we notice that a is equals to minus 1. By comparing minus h equals to plus 1, h is equals to minus 1. So once you obtain it, you rewrite this given function g of x is equals to s minus in bracket minus 1 minus 4. So once you have rewrite it, you can now describe it. It will be very easy for you to describe. Therefore, the graph, if you know, every closed function is in the horizontal axis, s-axis. The graph of g is a horizontal translation by a factor of 1 unit. This is negative to be to the what? To the left. 1 unit to the left. There is constant here. So having explained this here, like I've told you, remember to put here 6. So having explained all this, as you have seen, the graph of g is a horizontal translation by a factor of 1 unit to the left. There is a constant here, all depend on g of x. So this is only vertical we have. And vertical translation, and vertical what? So and vertical translation vertical translation done by a factor. I hope you're seeing it. A factor of what? 4. it is done by a factor of 4 of the graph of f. Of the graph of the graph. You must always put this graph because it is the graph it is affecting of f. So the graph of g is a horizontal translation by a factor of 1 unit, as you have seen it, and vertical translation done by a factor of 4 of the graph of f. So having stated this, you can now plot the graph. So the graph will look like this. I'm doing it in one graph. You know it's supposed to be 2. You first plot the first one you are given. You can do the first one. The first one will look like this. It's always so. This is the first one. This graph is a graph of f of x. So the second one, we are told that, looking at it, the graph of g is a horizontal translation by a factor of 1 unit to the left. It is somewhere here. Move to the left 1 unit. And vertical translation down by a factor of 4. Vertical translation down by a factor of 4. So it will look like this. It moves here. It first moves to 1 unit and move down. So the graph will look like this. The graph will look like this. So I hope you are seeing it. It will cut the S axis. It cuts the Y axis. So this is how it may look. Check this using the graphic calculator. Go to the website I gave you to confirm it. So the reason you gave, you must follow it with your graph. The graph of g is a horizontal translation by a factor of 1 unit. It moves here to the left. You first move here, and vertical translation down by a factor of 4 of the graph. It moves down by a factor of 4. So it will look like this. Because once it move here, mind you, here is the center. I didn't draw it to the scale. So here is the center because we are told it move to 1 unit. So it is the center. And then move down to 4 units. If you put it very well, it will stay called the y axis. But this is how it's going to look like. It must have an intercept on the y axis. So this is how the graph's going to look like. Have you any question? We can now proceed. All we have to be doing is just examples because I have already given you a table of value. Table of value explain whatever all the examples we are doing or I'm giving you. So that's why I say bring the table of value, so you'll be looking at it and seeing how the functions, the rules are being stated in our given example. So the fourth example is our fourth example is describe the transformation of g of x on f. This can be 3, but let's continue with 4. Describe the transformation of g of s on f and plot the graph. So this next is g of x equals to minus 2s raised to power 4. So which type of function is this? If you understand what we have been doing, because if you know the function, you can easily plot it. So what is the type of function is this? This is an open function because the exponent of the leading term only affect the s, it didn't affect the other one. For a closed function, g of x must be of this type. This is a closed function. We can now talk of the x size is horizontal, but this is open function. Then our lesson will be on what? Vertica explanation. The graph of g is a vertical stretch. So in this form, what did I say about this? Because there is no constant here, you can talk of what? Translation. We only if it is g of x equals to s minus 2 plus 4. This minus explain the translation on the s sizes. This one is will be explaining what? Translation on the s sizes, while the constant explain the vertical. But if it is in this form, 3s raised to power 4, 3, you will base on what? Because I say it's even, it is here, you will still base it. I don't know if it is governed on the s sizes. You see it's because it's odd, so let me still use even. So if it is in this form, it will be on what? All the explanation will be on stretch and strength on the s sizes, because it's a closed function. If it is in this form, please, if it is in this form, you better open the bracket, because it is odd. You can call it s raised to power 3 because it's odd, so that you can explain it in the vertical axis. But if it is even, you can still explain it in the what? Y axis, in the s axis. So this you can be explain it in the s axis. So you have to apply the knowledge of polynomial function we have treated, irrespective of this transformation. All the polynomial function rules we have treated, so you can be able to know, because cubic odd function, they always live like this. They are symmetrical on the y axis, not on the s axis. So it looks like this. This is a graph of f of s equals to s raised to power 3. Is it not my 5 and maybe 6? 6 seem to be 6, 9, 7. So while applying what we are doing today, you still have to be very careful. But this is in general, if it is in this form, whether it's even or odd, this is open. So therefore, you have to because it's even, you will talk of in the s sizes. Sorry, because there are some rules under which open and close doesn't function. So therefore, this must reflect on the what? S sizes. You must apply the knowledge of what we did, whether you are using the table. If it's not clear to you, apply the knowledge, because we are still within the range of minimum and maximum point we treated before. In this case, you see how the graphs look like. So from here, you can now, once it's in this form, there's no close, or you talk of stretch and strength. Because this is positive, you first explain it. The graph of G is a vertical stretch by a factor of 2 units. Sorry, let me don't confuse you. Sorry. For open function, please still talk of the vertical. But if you are talking of reflection, the reflection, that is where I'm trying to explain to you, not anything about the shrink, horizontal translation, stretch. No, horizontal translation, shrink, stretch, still obey the close and the open function, still apply it. But when we are talking of reflection always occur if the sign of what? The sign of the given function changes. If you look at this, the sign changes, will not talk of the reflection. In this case, if it is even, it will reflect on the x-axis. If it's odd, it will reflect on what? Y-axis. That is the clear explanation here. Close open functions still obey what I have told you, but if you, once the sign of the function changes, look at the exponent. If it is even, it will reflect on the x-axis. If it is odd, it will reflect on what? Y-axis. Therefore, the graph of G is a vertical because of this it's a whole number, vertical stretch of 2 units. It's a vertical stretch of 2 units and a reflection on the x-axis of the graph of f. All we have been treating is correct. So it is where I really wanted to refer on the reflection. Reflection will follow the sign of the exponent. Once the sign of the given function changes to negative, look at the exponent. If it is positive, it will reflect on the x-axis. If it is odd, it will reflect on what? Y-axis. Every other thing is still the same. So put your graph. This is always the same, and because we are told that it's a stretch, it will expand a bit because it's a mirror image. A stretch stay on the y-axis. So this is G equals to what? Minus 2x raised to power 4, and this is f of x. So this is how it looks like. The graph of G is a vertical stretch 2 units. Only the highest, like I have been explained to you, is still the same. Only the highest term, the leading term in a given function, explain how the graph of G has to be stretched or shrink. This is a factor, a whole number, so it is stretched. If it's a fraction, it will shrink. The negative indicates a reflection on the what? x-axis. Negative indicate the reflection. This is positive. This is even number on what? x-axis. If this is odd, this graph will look like this. You can always check this. This graph will look like this initially, because it will look like this. So if it's negative, this is negative and this is odd, it will look like it will a bit move away, because expansion is expansion. So this is how it may look, all passing through 0. This is f4 of x and this is what g of x. It will reflect on what y-axis because of the odd. This is y-axis, symmetrical on the y-axis. If it is even, if this is even, it will on the s-axis. On the s-axis. So we can proceed. We don't have any question, we may proceed. Any question? No question. So I'm giving more examples for you to understand. I will touch every examples that is necessary on that, so that all you need to do is just to look at the video, go to the class, and a question coming from transformation, solve it, have your 100 over 100, get all the marks. Any question? So we can proceed since you don't have any question. So the next is, if you are given g of x equals to s raised to power 4 over 2 plus 1. So this is what you are given. Describe the transformation of g of s on f and plot the graph. So we have treated whole number. This, what type of function is this? This is still a open function, therefore we are still talking on vertical. A graph of g, therefore g is a graph of vertical shrink. Guys told you this is a fraction, therefore it is a vertical shrink of half unit. We have what here? Plus. So we talk of translation and vertical translation. Vertical translation by a factor of what? 1. A factor of 1 of, always put, because this is what, where this g of s is from. Translation by a factor of what? Factor of 1 of the graph of f. So it is a vertical shrink of half unit and vertical translation by a factor of 1 of the graph of f. Once we have done that, you cannot draw it. I'm doing it differently this time. This is still f4 of x, this one. So the next is, it is a shrink, so the next is one. Here is 1. So you can still visit it. G is a graph of vertical shrink of half unit. It shrink. It is less than the size of this because it's fraction. And vertical translation by a factor of 1. Once it's shrink, obeying, you are still on it, it shrink, and then vertical translation, you move what up to 1. And vertical translation by a factor of 1, move 1 up of the graph of f. We're able to determine this because we know it's an open function, so all of have to explain is being vertical. So first we talk of shrink. Like I told you, shrink, stretch, obey the highest exponent of what? The given function, the first exponent. That is where you can interpret it. Then you go to the constant to see how the translation occur. So can we continue? More examples. We have another function this time. So if f of x, this is example 7, f of x is equals to 2s raised to power 3 minus 2s squared plus 6, and then you are given g of x is equals to minus half f of x. So you are required to describe the transformation of g of x on f and plot the graph. So this is how what we are given. This is sometimes in this type of example you have to apply the knowledge of plotting of graph of a polynomial function, which we have treated in the last lesson. In many cases you can make use of minimum and the maximum point I told you last time. So looking at it, this is multiplying minus half to this function. So this is the same as minus half in bracket 2s raised to power 3 minus 2s squared plus 6. So this will give us, if open bracket, this will give us minus s raised to power 3 plus s raised to power 2 minus 3. So this is what you will have. So in this case, I hope you are seeing it. So g of x, the effect of the transformation of g of x on f of x. So you need to plot this graph, the first graph. To plot the first graph, you have to understand the where it turns. So but you don't, if you want, you can still make use of the turning point. So this graph will look like this. This is f of x, this is 6, and if here is 5, so this is where the graph turns. This graph will turn like this. So this is the first thing. I hope you are seeing it. If you check the minimum and maximum point by dy dx, this occur at 2 over 3. Somewhere here, 2 over 3. This is 1. Here could be is minus 1 and 0. So you stay, and another point is at f of x equals to 6. So but this is how the graphs will look like. You can check the turning point, and then using the what we will learn about leading coefficients, and the leading coefficients, leading term here is positive, so it may start from here. It will start from here, leading coefficients. If it is negative, it will be like this, as inverted, something like this. It will be inverted. hope you are seeing it. So this is how it looks like. Find the turning point. So because the next is a mirror image, so here is 0 or here is 1. So when I find the turning point, I use turning point to solve this. The turning point of f of x, the f of x maximum minimum. When I find the turning point, I have 2/3. 2/3. When this is 2/3, y is 6, and I have 0. I have 5.7 for minimum and maximum point. You can check it, so you can plot this one. It is like this. So 5.7 somewhere here, sorry, this is 0. This is 2/3. So if it's 0, this is 6. If it's 2/3, around 5.7. So with it, you use the knowledge of leading coefficients and leading term. It will be like this, the graph. You can always check it with the graphic paper, the graphic online calculator. And I also find the turning point of g of x, maximum and minimum. You can check it, you can find the turning point. So when I find the turning point, I have 0 minus 3. I hope you are seeing it. The graph is always symmetrical about the y-axis, unlike what we have been doing before on the s-axis, minus 2.88. So you have to find the turning point. So the first is somewhere here. Here is 3 minus 3 minus 2. I get my first one here. So the second is somewhere here, around 0.67. I hope you are following. When s is 0.67, y is somewhere here. Then I get my second turning point. Because of this negative, I know it will be inverted. This is positive, so it is like this. So it negative will be inverted. A close tumbler. I hope you are seeing it. So this is how it's going to look like. You see they are the same, but the only difference is the changes, the reflection changes. So this graph is a reflection of this graph on what? On the vertical axis. G of s is a reflection of f of s on the vertical axis. So when you stated that, and a shrink, and it's a reflection on the g of s is a reflection of the graph of f of s on the vertical axis, and the vertical translation down by a factor of 3. I hope you understand it. I look at the intercept on the g of x. First is a reflection of f of s on the vertical axis, and the vertical translation down by a unit of what? 3. See it? Of what? F of x. Do you understand? This is the description. It is negative here. There is no negative here, so it is a reflection. They have the same parents term. Therefore, it must be a reflection. I won't check the minimum point and the maximum point by plotting it. So it is a reflection of It's a reflection of f of s on the vertical axis and a vertical translation of 3 down of what f of the graph of f of s, of the graph of what f of s, because the two function depends on x. Many times you see me writing f, it is still a function of x. Vertical translation down of the graph of f of x. Looking at it, you see what I'm saying. So any question, you must apply the knowledge of minimum and maximum point. Otherwise, you can still do it as we have seen. So, but once you got the first point, which is always, as we have seen, making s the if s is equals to 0. If s is equals to 0, this will be minus 2, minus 3. So, but you still have to get the second point. If you only based on what this translation you are seeing, so where can I get my second point? To get the second turning point, I have to find the turning point. If not, I can only use this one, and maybe I assume the second one is somewhere here. But this is how it looks like. Any question? But if you already mastered the leading point and the coefficients of all those leading coefficients, once you get this, you know that, because if it's positive, it will be in this type. If it's negative, it will turn. So you know that the second point will be in between, will not be greater than this, because it is the maximum. So it will be somewhere here. You can now apply the knowledge and plot it. This is positive. So once I get the first one, I know the rule, because it's positive. It's supposed to be somewhere here, and it cannot be more than 6. So it may be between somewhere here. I will now put it and there. So this is how it's going to look like. So more example for clarification. Have any question? Can I clean it? We'll now go for example 8. So for example 8, our example 8, before I give you some exercises you have to do this one first. Copy. You have to present this do this before we can continue. Do this. Describe the transformation of g of s of f and plot the graph. The first question, f of x, copy it out and do it. F of x is equals to s raised to power 5, and g of x is equals to s minus 2 raised to power 5 minus 1. The second one, f of x is equals to s raised to power 5, g of x is equals to 3 over 4 s plus 4 raised to power 5, and the third one, f of x is equals to s raised to power 4 plus s raised to power 3 minus 1. G of x is equals to f minus x minus 5. Please copy it out. Do it and submit it to me. I want to see how you can do it, because we have spent almost 1 hour, more than 1 hour 30 minutes. So I would like you to do this 3 and present it present them to me for marking. That will enable me know how you have understand what we have been doing. So, have you copied them? Pause the video, copy it out so we can continue.